So we're just going to say a quick hi so you can see us kind of on the camera. So I'm Dr. Nicola Knight, and my colleague is also in the meeting. Yeah.
Hi, I'm Dr. Samantha, the Pearman-Kanza, which is very long, so you can just call me Sammy.
Yes, so I'm going to start off by giving an introduction to the physical sciences data infrastructure, so PSDI in the UK, and then I'm going to pass over to Sammy, who is going to give an overview of our kind of current what we call Pathfinder activities and what we're heavily focusing on in this meeting, since we've got a lot of the NFDI people here, is alignments between PSDI and NFDI and potentially looking at some of the collaborations. So hopefully that should be a big topic in the discussions. I will preface this, it's going to probably be quite a quick overview because 30 minutes is not as long as it used to be for actually giving presentations. So we do have a lot of other stuff also available on our YouTube channel, or you can ask us questions in the discussion session. So let me get started. So obviously, data is massive in research, and the data is growing at like an unimaginable rate compared to previously available data, and the need for this collaboration around the data has never been clearer. Obviously this will hopefully not be a particularly sort of controversial topic given the most people's involvement in the research infrastructure. It's not just a research output, but it also drives future research. So PSDI is about connecting things. So it's a data infrastructure that's doing between experimental and computational facilities, mainly within physical sciences, but also beyond where the data is used elsewhere. So this is around data collection, integration, the curation, providing access to those different data sets, combining them across the different things. So this will enable physical sciences to really become digitally enabled, and also to support a lot of those resources beyond the sort of, individual research project. So really, this boils down to building bridges between different areas of the community. So some other countries already have initiatives in this domain. So obviously in some stuff in the US, Japan, some of the European stuff, clearly the German data infrastructure that most of you are probably part of. There are also other domains which have initiatives in the UK, so such as EBI for the life sciences, the NERC, which handles a lot of our environmental science data, and some of the stuff around social sciences. So really, it's a case of the UK is sort of catching up in terms of some of the other countries that are undertaking initiatives, but also within the physical sciences, there's a bit of a gap where we can catch up. So we are working towards, within the UK, building this infrastructure within the physical sciences, predominantly looking at the chemistry, materials and related disciplines, but also their interactions between the other domains such as life, medical, engineering, environmental sciences. So I'm going to give a quick example. So this is using biomolecular simulations. So often in terms of doing this, for doing trajectories, a researcher might sort of go through lots of manual steps, do lots of models, loads and loads of computations to actually build the trajectory. And then maybe they might do some of this supplementary information into their paper, but a lot of that knowledge in terms of what went into the research process is not recorded, is kind of lost. So this is looking at the process by which you go through in terms of what the researcher might do. So you'd run potentially a single command. So this is looking at the provenance kind of map in terms of all of the inputs, the calculation and the outputs that kind of go into just a single command, which is just one step in towards a simulation model. When you then, so in the center that is the calculation that's being run. And then up the top, you've got like sort of different parameters, inputs and outputs. And that's just one bit. So when you're going into doing the model, this isn't even the full simulation. This is just combining lots of different steps. The model that you're building then becomes very complex. And some of them are taking inputs and stuff from different sources. So this can then be used and go into a way that you can actually really track the whole process that goes through in the actual process that the researcher is taking. And then if you're actually looking at the whole study, this gets very complex, but it's very easy to actually map all the relations between the different interactions, and you can put this up into a database. And really, it's this whole contextual information that you need to get the full value out of the information. So this looks at actually being able to record this and then be able to credit different areas where you have different bits being worked on by different people. So they, in this Pathfinder, they're looking at recording this information. So they're basically looking to improve the data practices, but in a very simple way. So making it easy to capture the full data provenance of the stuff, collecting and integrating the different data sources, make sure that the stuff is compatible with other major data initiatives, and linking those computational and experimental data sources. So this is looking at building on the GROMACS software, which is the majority of the UK's kind of usage is within that software. And through making a package, basically, that is very, very similar to the normal operation that a user would do. So this is an AIDA GROMACS, one that they're looking at. And this basically, once you've installed the program, only requires one single underscore change to then capture all of that provenance information through AIDA, that then can just, is all done in the background. The user has very little additional stuff to do. And then that can actually then be used and examined further. So this is just one example of some of the work that we are undertaking. But there's a much larger picture, and this is just in the UK. So for instance, if we're talking biosim, we're talking one community within there, although it is obviously applicable across the wider thing. But we have very large facilities, institutes and hubs that often have potentially their own data infrastructures. Maybe some of them don't actually have the data infrastructures. You have a lot of national research facilities that service quite a few users, smaller communities of computational initiatives, and then what we call some of the long tail. So kind of disparate, very diverse sets of research institutions, those individual groups and laboratories that have a need to be able to capture their data, share it much better, and improve their data practices. So across the kind of whole scale, the breadth of the UK research community, and that is where we are trying to focus some of our effort. So I'm just going to give a quick overview of PSDI kind of to now. So we are obviously an ongoing project. We haven't been around for anywhere near as long as projects such as NFDI. We had an initial pilot phase back in 21-22, where we had some very short scale sort of prototyping projects and going out to the community, doing a lot of community engagement. And now we're currently somewhat in the middle between phases 1B, 1C. The terminology for the different phases is something that is changing a little bit. But we're kind of in the middle of a development project. So we've got a bunch of different Pathfinder activities that Sammy will present to you in a little bit. But we're kind of in our requirements and prototyping stage. Now we're transitioning into doing development and deployment so that we can then produce a platform where people can come access these tools, be able to interact with the data and use it on an operational platform, which obviously then will continue to be developed into the future. So this is a little glance of our pilot phase. So obviously this was a very short and sharp, I think it's about 4.5 months of activity. So we undertook a lot of engagement with the community. About 400 people contributed to the work that we undertook in this phase, and from about 50 organisations. And we undertook 8 case studies, this sort of little short areas, which were a mixture of discipline-focused investigations and some cross-disciplinary techniques. Some of these have continued on into Pathfinder activities that we are undertaking now. And as part of the pilot, we also came up with a selection of recommendations. So the full recommendations are available on our website, and we also have a bunch of reports that are available through our Zenodo community and on our website. I won't go into these all in detail, but these mainly focused around 4 areas, which are around connecting existing infrastructures rather than obviously building entirely new things, around the best use of data, the best use of people, and the best use of technology, which are kind of some of the key areas that we made recommendations in. So now moving on to our current work. So this largely divides into 3 areas. So we have our platform. So within our platform work, we are undertaking several scoping activities. So in particular, we've been continuing some of this requirements analysis from the pilot phase and through our Pathfinders, and also looking at the capacity planning. So this is both within what we have for our current work and also looking future into the physical sciences community. And we're also evaluating technology components. And then obviously this is going into beginning our system build, where there'll be building services that then will be deployed to the platform. So we currently have 7 active Pathfinders. So these are focusing on some of the key areas within domain-specific applications and some of the cross-domain investigations. So the example that I gave at the beginning of this presentation was Pathfinder 4, the process orchestration and the biomolecular simulations. And Sammy's going to give an overview of the Pathfinder activities in a couple of slides' time. So the other activities that we undertake within PSDI largely fit into the PSDI hub, which supports the project operation. So this is where some of the core activities are carried out to support the PSDI project. So these align, if you look on our website, with some of our work packages 1 and 2 mainly. So this is like the coordination, governance and management of the actual project as a whole, alongside the internal and external communications, our engagement and training activities, which, as John said at the beginning, is largely under my purview, but hopefully we might have some additional staff joining us in the new year. And then obviously, as the service develops further, we'll be taking some of the core infrastructure components, and those operation of those components will come into the hub so that they can be managed in the most streamlined manner. So obviously PSDI isn't intended to be a short-term project, but it has this long-term vision that will continue to be able to grow. So some of the other domains have been going with their infrastructures for some decades, up to 40 years or so. So it's not something that will just be one and done. We're looking at connecting those existing systems and then the generation of the adoption of tools that can be used across different applications. Obviously, the ultimate scope of PSDI is very large, so across the breadth of the physical sciences. Obviously, it's not feasible to achieve that all in one go. So in the shorter term, we're focusing on a smaller number of applications so that we can actually effectively build the infrastructure that a researcher would actually want to use and that it will be fit for purpose. So our Pathfinders serve the purpose of prototyping the platform and then refining these requirements that then are appropriate for their communities. So in the next phase, we'll begin to release the prototype services that are currently under development, and then hopefully we'll be bringing on some new additional Pathfinders to begin their development activities, and sort of the activities will go through a cycle of development and then into release. And then in phase 2, we'll be deploying these services as operational services, scaling up the adoption of these tools, and then beginning a further round of development activities. Naturally, alongside all of these development and operation activities, we're going to be doing the stuff in training, engagement, and community, both at a national and international level. So we haven't been funded for that long so far. So we're continuing to build the evidence to show the value of PSDI that it can bring, so that we can secure that longer term position. So obviously, international collaboration is a major thing. Research and data is not bounded by any international borders. So there are a lot of alignment with ongoing and developing international projects, and it's quite a feat to keep up to date with all the activities that are going along. Obviously, there are some major international things like CODATA, RDA, and World Fair, among many others that are involved in. But obviously, one of the major alignments would be how can we align or collaborate with the NFDI consortia. So in our next sort of section of the presentation, we're going to kind of focus a little bit on what activities we're doing and how might we align with some of the NFDI consortia. So most of you probably do come from the physical sciences NFDI section, so obviously this slide is probably not particularly unfamiliar to you. So we have looked at our alignment with some of the consortia within NFDI, and I think I've identified, it's 7 consortia that we align with most strongly. So these are Daphne, Fairmat, NFDI for Chem, Punch, Matverk, NFDI for Cat, and NFDI for Ing. So in some of the slides that Sammy will present, we'll focus on some of the ways that we might interact with those, and then we'd like to have a discussion at the end on some of the potential collaboration going forwards. So I'm going to pass over to Sammy.
Thanks, Nikki. So I'm just going to take you through each Pathfinder, give you a brief overview of the work that's being done in that Pathfinder, and then talk about where the different Pathfinders could align with the different consortia. So Pathfinder 1, this is all about experimental data capture in catalysis. So, as we know, chemistry research produces lots and lots of valuable, high-quality data. But unfortunately, our data publishing practices don't always support being able to actually reuse this data beyond the original research. And reproducibility is a massive problem. It's something we're looking at across multiple Pathfinders. And we're often missing provenance links between published results and supporting data. And ultimately, the whole thing is just very, very difficult to go from, here's the paper, I've got all the data, however well somebody's done it or tried to do it, kind of with limitations, and then actually properly reuse it. So to improve on the situation, in Pathfinder 1, they're running collaboration to try and define the requirements for different tools that would facilitate experimental data capture. And these tools would need to produce provenance data for all of the processing steps, provide references to all of the used data, and unambiguously map results to data object, and then produce the necessary metadata to enable that publishing. So this Pathfinder is researching 2 interdependent topics. So the first one is production of fair digital objects, and also the adoption of scientific workflows for processing and analysis. And the production of fair data objects offers the best viable solution to guarantee that published data can be effectively used for reproducing results, replicating experiments, and to support extended reuse in new research. We're also looking at scientific workflow tools like Galaxy, which incorporate many of the desired characteristics. So they're working with PSDI to create tools and workflows that can actually fulfill this and allow researchers to process and analyse their data, particularly the ones produced at large-scale facilities. So the team from Pathfinder 1 have said they've attended events in which they've seen proposals from NFDI, and they can see that there are many different areas where their research and NFDI's research overlap. And Pathfinder 1's really interested in the application of ontologies, vocabularies, metadata, and workflow management tools to support publishing and reusing data. So they've identified a number of potential opportunities for collaboration, which include Nomad, NFDI for CAP, VOCAT, React for, there's a lot of cats, I like it, Lab iMotion, and Rock IT. And these are all kind of different areas that Pathfinder 1 would be very keen to align with. So then Pathfinder 2, so this is my Pathfinder. So this is all about process recording. So ultimately, we're doing a lot of different things here, but everything we are doing and looking at goes back to kind of not just trying to make our data digital, which is still a problem, but also make it fair in all senses of the word. So we're looking at lots of different tools for scientists that they can use to record their research and their processes, whether that be electronic lab notebooks or generic notebooking tools, if that's more suitable for the work they're doing. We're also trying to understand the information flow all the way from lab notebook, ideally electronic, but there are paper lab notebooks still, unfortunately. So that kind of flow from starting with the lab notebook all the way through to thesis, papers, supplementary information, to understand what information is retained throughout, what gets left behind, of what gets left behind, what was actually potentially okay to be left behind, and what would have been really useful. And considering this really important question of, even if, say, I had all of somebody's research, whether, lab notebook, thesis, data, everything that they'd made available, or everything that they'd produced, would that be enough to reproduce the research or use it in the way that was intended, whether that's rerun the software, use the data, repurpose the data, replicate the experiment? Because I think, unfortunately, the answer to that a lot of the time is probably no. So it's really important that we don't just think about the tools and everything, but we also have exemplars, and we really start to think about, how would people use my research, and how can I actually record it and put it forward in a way that can make that happen? We're also really interested in interoperability in different forms. So we are producing a data format conversion service. And we're also conducting research into semantic web technologies and how these can be used to help with fair research, and also be used to the best of their abilities, which I won't go on about too much because I could do a whole different presentation on that. But I will prefix, I love the semantic web, but I still don't think we always use it to the best of its abilities. And it's really important that we are going to use it, we use it well. So we've got a couple of existing collaborations in the UK and internationally. So we're looking at PSI data and conversion methods for semantic data. Also the ELN Finder project, which enables scientists to choose between different ELNs using lots and lots of different criteria, which is useful because there's so many out there and people don't actually know what most of them do, which can be a bit of a problem. But sort of looking at other potential areas of alignment with NFDI, we've identified 3 main areas. I think the one we do overlap with the most is NFDI for chem, in quite a few things, fair data publishing, the terminology service, and also, of course, the Chemotion ELN, but also with FairMat and Daphne on the areas of fair data and metadata. And we've also got Pathfinder 3. So this is building data collections. So one of the big things this Pathfinder is looking at is producing high quality curated data sets for a range of different areas in the physical sciences. So we have created some data sets both from legacy projects, which was an eye-opener, and some current projects, in some ways actually also an eye-opener. And through that, we've learned a hell of a lot about the pitfalls of trying to record and publish scientific data, even when someone thinks they've done it really, really well, and it hasn't necessarily been the case, and where things kind of go wrong, particularly with reference to databases and websites and code and such like, where that's gotten quite a lot more complicated. And I think everything that we've learned is enabling us to produce better guidance about publishing and sharing scientific data. And we want to produce some formal guidelines on that, which will kind of link in with the exemplars in Pathfinder 2. And we're also looking at a range of institutional repositories to understand what options are out there for our community and where certain ones might be more suitable in other areas. So we also have several ongoing collaborations with institutions and projects in the UK for this Pathfinder. And shockingly, because we actually align quite strongly with Pathfinder 2, the areas of alignment are also fairly similar, namely in NFDI for Chem and Daphne, though in slightly different areas, very much around the repository side of things, but also with NFDI for CAT and the kind of links to guidelines on data, because I think it's really important that we consider that from all different angles and people collaborate cross, well, I suppose it's all the same discipline, but cross sub-discipline. Now we've got Pathfinder 4. So Nikki did tell you a bit about this earlier, but this Pathfinder aims to establish tools and an infrastructure prototype for capturing the full data provenance for biomolecular simulations, starting from experimental input data all the way through to those final publications. They're most closely aligned again with NFDI for Chem. You guys are super popular here, and FairMat. And in future, they're also going to be working with the Molecular Dynamics Data Bank. So they'll be collaborating with through EBI with European partners. And we've got Pathfinder 5. So this is data to knowledge. And this is exploring infrastructures and workflows for supporting generation and interrogation of machine-learned interatomic potentials in a reproducible manner. So they've devised a proof of concept system that would be installable centrally within PSDI, with blueprints that are provided to enable local user installation as well. And in the system, users can interrogate, download and deposit data via both an API or a web interface, depending on your preference. And this system is intended to be integrated into machine learning workflows. Ultimately, the aim is for a user to be able to access this via a browser, select the data in the machine learning model, and then run this to create a potential. And in the background, this process will automatically be recorded. Just a slight little plug here, Pathfinder 5 is going to be the focus of our next PSDI webinar. So this is on the 14th of December. I'm sure you cannot think of anything else you could possibly be doing with your day now you've heard this. So please do sign up via the events page on the PSDI website.
So then we have Pathfinder 6. This is one of our newer activities and it focuses on NMR crystallography. So CCPNC supports a multidisciplinary community of NMR spectroscopists, and I'm sure most of you know what NMR stands for, but in case you don't, it's nuclear magnetic resonance. And they also support crystallographers, materials modelers, and application scientists by developing computational data processing and visualization tools. This initiative combines the use of experiments and computation to provide new insight with atomic resolution into structure, disorder, and dynamics in the solid state. This field has recently been recognised by the IUCR, the International Union of Crystallography, and creates the MAGRAS file format for unified representation of crystal NMR parameters, which has been adopted by density functional theory DFT codes such as CASDEP and Quantum Espresso. So this Pathfinder has a couple of objectives. Firstly, their Magres database is home to about 5,800 Magres file entries from the community users, and the database website is currently undergoing a lot of improvements as they want to have a quicker search, to add Boolean search features, enhanced file handling, and to improve their metadata. They also want to develop a new database website aiming for emerging standards and technical stacks, enabling cross-referencing through Optimed integration, fair data, and integration of data visualization tools.
Pathfinder 6 have recently had a productive discussion with developers from Nomad, which started from our request for updating their parsers to actually add support for the Magres files. And the discussion has developed further, touching on potential future collaboration in lots of different areas. These key discussion areas were database integration, helping with making Magres data fair, adding DFT workflows, including search parameters in Nomad for NMR crystallography, extending the database services to our experimentalists, and adding CCMP supported data visualization tools to Nomad. And our final activity is looking at reproducible computational workflows in Galaxy. So this uses the Galaxy platform to manage computational workflows associated with large-scale experiments that are performed at the Rutherford Appleton National Laboratory. So Galaxy is an open web-based platform that's accessible, reproducible, and transparent. So accessible because your programming experience is not required to easily upload data, which is good. So there's a low barrier to entry, and you can run complex tools and workflows, visualize those results. It captures information so that users can repeat and understand a full computational analysis from tools to parameters to dependencies, so it's reproducible. It's transparent because users can share and publish their histories and workflows and visualizations via the platform. And it's very community-centered. So they have a lot of inclusive and diverse users, developers, educators, researchers, clinicians, and they all like to share their findings with each other, which is really nice. So the picture shows what the Galaxy, on the slide shows what the Galaxy platform looks like. The tools are on the right side of the panel, and then the center panel shows the parameters of the corresponding tools. And then on the right, there's the story of the data files, inputs and outputs produced by the Galaxy tools. And we're using the Galaxy platform to manage workflows associated with two types of large-scale experiments, muon experiments and X-ray experiments. For the muon experiments, they've developed the software tools for modeling and interpretation of those muon experiments. And these tools, based on computing simulations such as DFT simulations, were created using associated Galaxy tools and a Galaxy instance for the muon experiments. For the XAS experiments, the software tools for processing experimental data are already available, and they created the associated Galaxy tools and Galaxy instance for processing the experimental data. So this Pathfinder has identified 3 potential areas for collaboration. As is NFGI for CAT. They're currently working on Galaxy tools for processing workflows associated with catalysis experiments, which is a collaboration with the Catalysis Hub and the Diamond Synchrotron source at SGFC, and their collaboration with Pathfinder 1 as well on this. With regards to Daphne, they're currently collaborating with US colleagues on Galaxy tools for neutron and X-ray experiments. And for Matt work, slightly different scientific area, but they still seem some potential alignment, such as the 3 that they've highlighted on the slide in blue, because they're dealing with simplifying, processing, recording, and managing scientific workflows, and Galaxy can obviously help with that.
Cool. Thank you very much, Sammy. So that was a whistle-stop tour through the Pathfinder activities, as was noted on some of the bottom of the slides. Some of these Pathfinder activities have already presented in the PSDI webinar series. So if you are interested in their activities, you can find recordings for most of them. Some of them will be available shortly when I've finished editing the recordings, but some of them are already available on our YouTube channel. And obviously, as Sammy said, Pathfinder 5 is going to be presenting at our next PSDI webinar. But obviously those are kind of our specific applications that we're looking at within our activities, but there are also a number of topics across kind of the wider project that we have identified as kind of wider areas for collaboration. There are probably more areas than we have already put on this list. However, some of these that come up across several different areas are best practices. skills and training, both in terms of general data skills, but also specific training for tools or kind of developed services, the standards that are both available and also implemented, both in terms of file formats, but also for metadata standards. The wide-ranging topic of publishing and sharing data, which has a lot of facets inside it. And then the topic that I'm sure Sammy could wax lyrical on for several weeks, semantics and ontologies. Obviously, these many of these require kind of collaboration on both, like within a community and on a kind of international scale, because as I'm sure most of you are probably familiar with the XKCD comic around standards, is that obviously everybody will just say, oh, well, we just need another standard to unify the standards, and then suddenly you just have more competing standards, rather than actually kind of aligning and simplifying the problem. So in terms of enabling sort of collaboration and communication, we have so initiated between John and myself and Sammy out of the an ACS presentation where we realized that actually we should talk to each other's projects more. We have started a communication network map. So this takes a variety of the different projects across NFDI and PSDI, and then we've identified some kind of cross-project topics that would be useful to have collaboration or information on, and the focus of this map is to kind of enable people to find the best person within a project to kind of go and speak to as a first point of call when they're interested in talking to that project about what they're doing. So some of these, this isn't the full networking map, it's quite zoomed out when you go for the whole thing, is kind of around obviously, like say, skills or training. There's a section I think on ontologies, around data sharing, and it gives the kind of people that are the primary point of contact, rather than going through just the coordinators kind of every time. Obviously NFDI, often they have more than one coordinator for the different areas of the project. I am the main coordinator for PSDI, so this will enable people to go directly to the best person. So I think actually that is basically, we've kind of got to the end of our slide deck, which is pretty well on time, which is quite good. So yes, obviously a bit of a whistle stop in terms of some of the stuff, but we're happy to move on to questions, discussion.